All right. Good morning, Angelo. Good morning, Ethan. Good morning, Dylan. Good morning, Rod. Good morning, Megan. Good morning, Rubab. Let's see. Good morning, Dari. Good morning, Azima. Good morning, Jolie. Good morning, Owen. Good morning, AJ. Morning, Emily. Good morning, Sebastian. Good morning, Nora. Morning, Madison. Happy Wednesday, everyone. So like weird, I feel like that we have a different schedule when we're all home. I was like ready to go at 7:45, and then I'm like, oh yeah, school doesn't start today at 7:45. Good morning, Marissa. Good morning, Maya. So I don't know, it's just strange. I think that's all I'm trying to say. It's strange. Morning, Kane. And I feel like someone else just got here. Morning, Jahanzeb. Good morning, Michael. All right, let's go and get started, shall we? I got some would you rathers that I thought we could start class off with. Is fun, so I'll put you into just partners, random partners in a moment. Give you a couple minutes to talk through these, so you can grab a quick photo of this. Take your phone, take a quick screenshot of it, or take a screenshot on your iPad, something. But grab that so you can look at these and talk to these with the person you're partnered up with. When you get to your room, because it's going to be someone random, while I'm talking, let me get that going. Let me get the breakout room set up here. When you get to that room, go ahead and introduce yourself, because you want them to know how to pronounce your name, and they want to know how to pronounce your name. Okay. Cool. There we go. So it's just you and the other person, just two of you. Oops. We got to click. There we go. So enjoy these 2 minutes together. These are kind of some, always fun would you rathers to discuss that, but just discuss anything you like. Otherwise, just enjoy these 2 minutes with somebody else. I recommend please have your video on, so that you can see each other. Excuse me, and certainly be unmuted. All right, guys. Let's see you back here in 2 minutes. Have a little fun with each other to start class off. Bye. Oh, Michael, wait, no. Are you here? No. What's going on? All right, everyone, welcome back. I hope you had a little fun with the other people. It always makes me so happy when you guys come back and your videos are all on, or most of your videos are on. So I know that you guys were really talking to each other. I appreciate that. Would you rather have your very own house next to your parents' house or live with your parents in a house that's twice the size of the one you live in now? I don't know how you guys feel as teenagers, if like you'd still want to be living with your parents right now, or but I definitely would want my very own house. Love my parents, don't get me wrong, but I also like having my space. So there you go. That was the one. I mean, I had to talk about that one because it's about parents and stuff. But the one that really stood out to me was the first one. Would you rather never eat cheese again or never drink anything sweet again? Whew, I would actually. This might surprise you. I think I would give up drinking anything sweet again. I do really enjoy cheese. All right. I hope you had fun. I think those are fun. So let's do review. Before we jump into review, let's just kind of remind ourselves we got our summative tomorrow, right? And so a couple of things I just want to remind you of. If you guys, while I'm talking, would you go to the summative and just, sorry, the formative that we did on Monday. And unfortunately, I know like not all of us did put in the time to take it. And if you didn't, that's okay. But or you should. I did put the key there, so you can, what you can do between now and tomorrow's summative is you can take the formative without looking at the key, and then you can kind of grade yourself. That shouldn't be too bad. Um, but it's there for you. But if you did take it, please take a moment, look at the formative, and read my feedback to you, just to remind yourself what you really need to be focused on. Is it LT5a? Is it LT5b? Is it multi-step problems? Is it remembering that the denominator, the distance is squared? So just take a minute and look at those. While you're doing that, I'm just going to talk a little bit. There's all these things to be studying tonight. I've got answer keys, I think starting back, with day 9. So answer key to that, and LT5A, answer key to Coulomb's law, answer key to LT5b, answer key to the multi-step problems, answer key to the big formative, and in case you didn't notice, I did put the answer key to the review up there as well. Okay. Oh, okay, Megan, thank you. Oh, there she. Oh, okay, great. Okay, thank you for that. Cool. Jolie, are you here now? Okay, I think so. Good.
Yeah, thank you.
Sure. Sorry. Thank you. I saw somebody appeared and then it didn't. It like disappeared off my screen. So whatever. Okay, Mara, I will grade that then. Thanks. I see your message. Just stick around right after class and just remind me, and I'll do it right away. All right. Anyway, so there is all that. There's so many good things to study, and what I'm going to do is I'm going to email you links to the last like 5 days. So if you want to watch the videos from the last 5 days, that'll be available to you. So there you go. So much good stuff. But I want to pick up where we left off yesterday, which is on the review. So go ahead and open that up, everyone. I'm going to pull up my iPad so we can keep cranking away at it. And I think we got through almost 4 problems yesterday. I'd like to get through 4 today, hopefully. And what we'll do is we will do, just a moment here. There we go. We're going to do the last 2 in LT5b. So scroll all the way down to the bottom there. We'll do those last 2 first. And then I want to do the 2, I'm going to have to jump to a different file, the last 2 on the previous page. Yep, that's the plan. Okay, here we go. So let's start here with number 8. And we'll do the thing where I'll let you work on it and then give me a signal as far as when you have completed it. So I'll help you out. Remember, when it's LT5b proportional reasoning, we want to put our placeholders in there. So we got placeholder force equals placeholder K, placeholder Q1, placeholder Q2 over placeholder distance squared. Okay, so I don't want you to do part B, just do part A. Part A, I think, is the most difficult part. Let me pull this up so I can see all of you guys. There we go. So just give me a signal when you have finished attempting part A, please. Thank you, Arad. Thank you, Megan. Thank you, Jolie. Thank you, Dari and Madison and Owen and Mara, Ethan, Angelo, Rabab. Okay, great. I would imagine that everyone's had enough time at this point to try it. So let me give it a go myself. All right, so the first thing I'm gonna do, I'm just gonna throw 1 in front of that K, right? I mean, at this point, I think we're all very clear on that. You know, we can change distance, we can change the charge, we can change the force, but we can't change K. It's 9 times 10 to the 9th. So we can't change it, so it just gets a 1. All right, by what factor would the force change? So that's our question mark. If the charge of A remained the same, but the charge of B changed by a factor of 5, and the distance changed by a factor of 1/9. Okay, I like this one because a couple things that were common issues with LT5b. Number one was remembering this squared, carrying that squared through your work. So we'll get to touch on that. And number two, algebra. Okay, so I'm gonna go ahead and solve this one, and we'll kind of like pay attention to those two things. So the equation that we get out of this is question mark equals 1 times 1 times 5 over 1/9. Don't forget the squared, right? Carry the squared through. So what is this simplify to? Question mark equals 5 over 1/9 squared is 1 over 81. So 1/81st. Make that 8 a little better. There we go. Now, one thing that I talked about before, algebra-wise, is when I've got something over a fraction, when I got a fraction in either the numerator or the denominator, I like to make both of them a fraction so that you can multiply by the reciprocal. So what do I mean by that? Well, what I mean is like I'm going to make this a fraction. So it's instead of 5, it's 5 over 1. And that whole thing's over 1 over 81. And now I can multiply by the reciprocal, meaning I can multiply 5 over 1 times the reciprocal of the denominator. And so instead of 1 over 81, it's 81 over 1. And so then I think I just did this a couple periods ago, but I'm pretty sure that comes out to be 405. So 81 times 5, yeah, 405. So there we go. Give me a signal. How many people got 405? I miswrote it. How many people got 405 for this before me?
Couldn't you just write 5 over 1/9 squared in the calculator?
Yes, absolutely. Thank you, Jordan. I was just about to bring that up. So cool. So I was over half, I'd say. Give me a thumbs up with the 405. So to address what Jordan said, that was literally what I was just about to say. And some of us get a little freaked out by all this like fraction algebra work. And I just want to tell you that if that's you, if you don't love doing that or don't want to do that, then you are welcome to plug it in your calculator. And so exactly like Jordan said, you could have put 5 over 1 over 81 into your calculator, and that would have given you 4 or 5. Now, yeah, let me show you. Let's do that real quickly in that Archimedes calculator that we have. There we go. So it was 5. Okay, so go to the next line. Okay, so it was 5 over 1 over 81. Okay, and so what we see is this is good to go. And you can, the reason I'm saying this is good to go is because the large divider, that's like below the 5, that like divider is larger than the one that's between the 1 and the 81. And so it's telling us that it put the 1 and the 81 in the denominator. Okay, so yeah, there we go, 405. Cool. Good. Any other questions or comments?
Did you just do 81 because you knew 9 squared was 81?
Exactly.
Okay, so if we write like 9 squared, it'll still work. The square doesn't have to be for like the entire fraction of 1/9 when typing it into the calculator. If we
Right.
like connect it to the denominator, it'll still work.
Yeah. You
Okay.
could have done 5 over 1/9 squared. Is that what you're saying?
Yeah, thank
Yeah,
you.
totally. Thanks, Julie. That's a good call. All right, great. So let's try this one. Go ahead, just do part A. And so I mean, then for part B, the question is, what would be the new force? We see the old force is 0.08, so then you just do like 405 times 0.08, and I'm not gonna take the time to plug that in my calculator. The answer key is there. Hopefully this is pretty straightforward. You guys get that. But so take a moment, give me a signal when you have tried 9, just part A, just part A. Okay, sorry, I just looked up. But thank you, Azima and Arad and Ethan. If anyone else had already signaled, please give it to me again. I was getting things set up on my iPad there. Oh, wow. Great. Megan and Rubab and Angelo and Dari and Jolie and Jordan. Thank you. And great. Mara. Okay. Well, let me go ahead and do this. Let's see. Again, I'll throw that 1 in front of the K because it can't change. It's 9 times 10 to the 9th. By what factor would the force change if the charge of B remained the same? So we're wondering the force change if the charge of B remained the same. Oh, so we'll call that Q2. It probably makes more sense. But the charge of A changed by 1/3, and the distance changed by 8. Okay, so our equation is going to be question mark equals 1 times 1/3 times 1 over 8 squared. So I'm going to go and do all that algebra again. But at this point, like Jordan mentioned, you could just throw this in your calculator. And I'm going to do that after I do the algebra, just so we can see what that comes out to be. So this is 8 squared is 64. So this is question mark equals 1/3. There we go, over 64. So I'm going to turn that 64 into a fraction. So instead of 64, I'm going to make it 64 over 1. So I can multiply by the reciprocal. Again, the reciprocal means you take the denominator and flip it. So question mark is equal to 1/3 times 1 over 64. And so then 3 times 64, let me just do this real quick. 3 times 64 is 192. So question mark equals 1 over 192. Now the reason I'm going to plug this in my calculator is because I'm okay with you saying that's the final answer, but I'm also okay with you giving me the decimal value of that. And so you would get that decimal value if you plugged in the calculator 1/3 over 64. So let's do that, 1/3 over 64. And I think we're going to see something interesting here. 1 divided by 3 divided by 64. Okay, so I want to point something out to you, and this is really important. The Archimedes calculator is doing the wrong thing. And so maybe, I don't know, for small calculations like this, you might want to use your regular phone calculator, or you need to understand, we want the 1 and the 3 to go together. We want that to be 1/3. Instead, it's making the 3 and the 64 go together. It's making it 3/64. You see that? And you can tell that by where the big fraction line is and where the small fraction line is. So here's what you do. Highlight the
parentheses, right?
Yes,
Over.
exactly. We're just going to do parentheses. So just can we do it all at once? No. So you're going to have to get rid of that 64 if you're stuck where I am. There we go. And then you want to put parentheses around the 1/3. So I highlight it and I click the parentheses button. There we go. Now I do divided by 64, and then I get the answer. Okay. So 1 over whatever it was, 132, I think it was. 1 divided by 132 is the same thing as 0.0052. So either of those, I would be totally satisfied. So if you wrote your answer as 192, 1 over 192, or 0.0052, I'd be okay with either of those answers. Okay. Are there any questions? Any questions? Cool. So last thing I'll say is that then, obviously don't forget to do part B. We're not really putting a lot of time into it today, but because it's fairly easy. So what would be the new force? So we'd go the force right there, 0.006 times 1 over 192, and that'll give you your answer to part B. Okay. One last thing I want to say before we move back to LT5a and multi-step problems is this. Those are the 2 easiest on this page. So the ones we did yesterday, the 2 harder ones on this page, because they're 6 and 7. So, when you're studying tonight, make sure you're thinking about that. And why do I say they're the harder ones? It's because 6 and 7, the question mark, or at least I think they're the hardest ones, the question mark's in the denominator. So it says like, what factor would the distance change? So we're looking for that. And remember, my advice is when you're solving for something in the denominator, your first step should be to multiply it to the other side. Okay. And so you'll see we did that in 6. And you also see that we did that in 7. can see that right here. We had that question mark. That's what we're solving for. And so we multiply it to the other side. All right, good. Any questions before we move to LT5a, multi-stepped? Good. I do want to say, so for LT5b, if you did the formative and you got a 3 on it, then, I would say you're in pretty darn good shape. If you're feeling like the last 2 days doing this stuff, you're feeling pretty confident. If you did the formative on LT5b and you got a 2 on it, I would definitely say, you should find some time to study after school or, outside of our class. And if you got a 1 on LT5b, then it's good that we've done this stuff in class, but you absolutely got to find some time to do a little extra study, right? So what might that look like? You just grab a blank copy of this and you try this on your own, or you look back a couple days ago and you find that there's there's a day that says LT5b and there's some problems there that you can practice, right? So just make sure that, you're aware that like, this may not be the point that you want to stop. You might want to, study beyond what we've just done as far as LT5b goes. And I'll say the same thing with LT5a, like look at your formative, see how you did on it. If you got a 3, then maybe, if you felt good about the last 2 days, then maybe you're good for tomorrow. But more than likely, you're going to want to find some time to study a little extra between now and tomorrow. So, especially if you're a 2 and absolutely if you're a 1. All right, so let's dive in to number 3 right here. Now, I just want to remind you guys, Megan asked, I thought, a really good question. She was like, how can I understand and figure out, like, in LT5A if it's a multi-step problem or not? And so I just want to remind you, like, kind of by reading through this one, how we do that. So I'll help get us started on that, and then I'm going to give you a little time to do it on your own. A balloon and a pith ball attract each other with a force of 0.5 newtons when they're held 0.03 meters apart. Calculate how many extra electrons the balloon has if the pith ball has a charge of positive 4.3 times 10 to the negative 8th. Okay, so our goal is to find out how many extra electrons the balloon has. Okay, so right away we know which equation we want to use, and that's Q equals NE, right? Because extra electrons is N. So that's what we're trying to find, that N. All right, so we know E. So we got like E is one. Remember, it's the constant charge of an electron or a proton. It's 1.6 times 10 to the negative 19th. Okay, so we know E. All right, so there we go. So if we're solving for N, we just need Q. All right, so let's reread the problem and see if we've got Q. We got E. A balloon and pith ball attract each other with a force of 0.5 newtons when they're held 0.03 meters apart. Calculate how many extra electrons the balloon has if the pith ball has a charge of 4.3 times 10 to the negative 8 coulombs. Now, people will be tempted to plug this in for Q, but that is not this Q. That's not this charge. This is the charge of the balloon. This is the charge of the pith ball. We don't want to, if we're trying to find the number of electrons on the balloon, we don't want to put the charge of the pith ball in there. That just doesn't make sense. We want the charge of the balloon. So what we quickly discover is we have 2 question marks, 2 unknowns. And so that was my explanation yesterday. If you try to solve the equation and you realize you have 2 unknowns, then that means it's a 2-step problem. If you try to solve the equation, you just have 1 unknown, then you're good to go. All right. So you're going to start over here. F equals K Q1 Q2 over distance squared. And so you're going to solve for Q2 and then plug it in here. And by Q2, I mean the charge of the balloon. All right. And then you'll be able to solve for the N right there.
Oh, what's F then?
The force.
Yeah. Oh, right, force. Okay.
Okay. So I'm going to let you guys work. And I realize that this is a 2-step problem. This might take a little time. I'm not going to rush us. We have 15 minutes left in class. So maybe 3 to 4 minutes on this. 3 to 4 minutes. I'll give you 3 to 4 minutes on this. So, but give me a signal when you've tried to solve this problem. Cool. Thanks, Arad. Thank you, Ethan. Thank you, Angelo. Thank you, Madison. Thank you, Megan. And again, in my opinion, this is a little bit of a more difficult math problem, so I don't want to rush us. Do give me a signal when you've finished solving for n. I thought you already signaled, Angelo. Cool. Great. Thank you, Zima. Thank you. Thank you, Kane. Thank you, Owen. Thank you, Mara. Great. So I'm going to go ahead and jump in myself. Again, I just want to, as I always say, please make sure that you're trying these. You will get just a million times more out of this if you're trying it, other than if you're just watching me do it, you're not going to get nearly as much out of this. So, all right, so here we go. All right, so a balloon and a pith ball. You know, real quick, Maya asked, how do you determine which equation to use when the question asks for force or how far apart the objects might be? And so Maya, just to quickly answer your question, in both those, if it was either of those cases, you'd be using this equation right here, because this equation only has force in it, and this equation is the only one that has distance in it, right? See, the equation over there doesn't have force, nor does it have distance, okay? So if the problem asks for force or distance, then you can be confident that that's the equation you're going to be using. Does that help? Is that good, Maya?
Yeah, but also, like, I'm kind of looking off the key as well for this. How they use, like, first they use the Q equals NE, but then they also use the F equals K. How do you, like, figure
For
out if
number
you...
4, you mean?
Yeah.
Yeah, okay. Well, 4 is next. So hold on. We're doing
Okay.
3 right now. And then I'll address that question then. All right, so let me get 3 wrapped up here. So the force is 0.5 newtons equals K, and K we know is 9 times 10 to the 9th. It says when they're held 0.03 meters apart. So I'm going to go and do 0.03. And remember, that's squared. Calculate how many extra electrons the balloon has if the pith ball has a charge of 4.3 times 10 to the negative 8th. So that's Q1, and there's Q2. So I'm going to switch over to the calculator app. And what you're going to watch me do is this. I am going to plug all of this in right here, like so. And then I'm going to get a value, and I'm going to divide that value over. So I'm going to do 0.5 divided by that value. Then whatever that value is, that will be Q2, right? So then I'm going to plug it in over here, and I'm going to take the value that I get. I'm going to then divide by this E, right? And let's remind ourselves what that E is. That E is 1.6 times 10 to the negative 19th. So I'm going to divide by 1.6 times 10 to the negative 19th. Okay, let me go jump over to my calculator app. I already have those numbers written down. If you know, one thing I want to remind you, I saw a couple students download it on their phone. If you can download that app, the Archimedes app on your phone, that might be really helpful, so you don't have to be bouncing back and forth. Because I keep it on my iPad so you can see me typing. I have to keep a little scratch paper handy. You might want to do that as well if you're just going to work with it all on your app. All right, so let me just go to the next line and start fresh. So like I said, I'm multiplying all that stuff on the right. So that was 9 times 10 to the 9th times 4.3 times 10 to the negative 8th divided by 0.03 squared. All right, so it's 430,000 is what we got there. And now I'm going to divide that to the other side. On the other side was the 0.5. So I'm going to go start a fresh line. I'm going to do 0.5. I'm going to divide it by, and if you remember, if you swipe left on the keypad, you can see answer as an option. So I get 1.16 times, I'm rounding that, 1.16 times 10 to the negative 6 is what I get. Now I'm not done yet. So that 1.16 is, remember, that is this Q over here. So I'm going to plug that into for that Q, and then I'm going to divide the E over. I'm going to divide that 1.6 times 10 to the negative 19th over. So I'm going to do Q that I just got on my calculator divided by 1.6 times 10 to the negative 19th. And that will be my answer. So again, I'm going to go to a fresh line. I'm going to take that answer, that number we just got, I'm going to divide it by 1.6 times 10 to the negative 19th. And now I have my final answer of 7.26. I'm going to round that to like 7.3. 7.3 times 10 to the 12th. Did anybody get that before me? Give me a signal if maybe you did. 7.3 times 10 to the 12th. How many people got it? We just do a count. I'm not, no names. I just want to go 1, 2, 3, 4, 5, 6, 7, 8, 9.
Do we not get an actual number for the answer? Do we just leave it as the 7.26 times 10 to the 12th?
Yeah, but that is an actual number, right?
Can you not like simplify it to an actual number, or you just leave it like that? Like press answer and get the number?
I'm not sure, Jordan. Like, because the thing is that I guess I'm not sure what you mean by actual number, because I would say that
Like,
is an actual number.
Okay.
Is that okay?
Yeah.
Like, for example, like I could write 100 as like 1 times 10 to the second. That's 100. So like 1 times 10 to the second is a real number, just like this. Is that okay?
Yeah.
So there we go. Great. A lot of us got that. Mara was saying, hey, Mr. Rosaday, I got 7.25 times 10 to the 18th. So are you sure it was to the 18th? Mara?
I think so.
You think so?
I rounded more, or no, I didn't. I added for like the first part for the
Yeah.
1.16. I added the 2, so it was 1.162.
Okay, well, here's what I'll tell you. 2.75 is fine, but if it's to the 18th, that would be a problem. Like rounding, like, because this is like, the answer was like 7.3 times 10 to the 12th. So maybe you actually were to the 12th. Does that make
Yeah,
sense?
I did mine a little different, like the first part. So I don't know. I'll try
Yeah.
like the way you do it. next
Okay,
time.
yeah, do that. Because like, absolutely, if like the exponents should be the same, like times 10 to the 12th should be the same. But if that first part's a little different, no big deal at all. But I'm also going to say one more thing that I said yesterday. If you remember, I said that like, this is physics class. This is not calculator class. You know, obviously I want you to do this. I want you to do this as best as you can. But like if I can't emphasize enough how important it is that you show your steps. So like, it's way more important to me. That's the wrong one, I think. Just one moment here, guys. Sorry. It's way more important to me that you, that was okay. Sorry. This right here. Way more important to me that you show me all this work than you get the right answer. Because if you show me all this work and you get the wrong answer, I'll still probably give you a 3. Okay. Unless you get like every single one wrong. If you get every single answer wrong and you show me all the work, I probably would have to give you a 2. But again, this is physics class, not calculator class. I want you to be successful. Like I want you to know how to plug it in your calculator. But like, it's way more important to me. So show your work. Show your work. Megan, you have a question, I see. Yeah.
Yes, yeah. I feel like I've asked this question like 50 times, but I just want to make sure. So because you just rounded to the 10th for that last problem, is that kind of like an expectation? Would you like the 10th?
No, I would say 1 or 2 decimals. I always round, personally, I round to 1 or 2 decimals, and that's totally fine. So it's your call. And like you know, like Mara was, hers was like 7.25. That would be fine with me, as long as the exponent's correct.
Okay, thank you.
Sure. All right, good. We have 6 minutes. Let's go and do number 4. And I want to kind of address Maya's question, because Maya was really, I think the question, Maya, that you asked in the chat is really that question that Megan asked yesterday, which is like, how do I know which equation to start with, and how do I know which equation to finish with? Okay, so you know, or actually, it's connected to that because Megan's question was like, how do I know if it's a multi-step problem? And so like really, Maya's question is, how do I know which one to start with and which one to end with? So I'm just gonna kind of dive in a little bit to help out with this one. So follow my thought process, everyone. So we've got a glass rod is brought 0.06 meters away from a pith ball. The glass rod is missing 4 times 10 to the 13th electrons. What is the force between them if the pith ball has a charge of 6.2 times 10 to the negative 7th coulomb? So I see it's asking me for force. So right away, I know I'm going to start with this equation. F equals K Q1 Q2 over distance squared. So let's start plugging in numbers. We wanted to find the force, so I'm just going to leave that as F because that's what we're finding. So K we know is 9 times 10 to the 9th. Okay, and let's see, a glass rod is brought 0.06 meters, so I know that's my distance, so I'll go 0.06, and I know that's squared. Let me zoom in a little. I think that's why my stylus is being a little strange. There we go. That far away, I'm right here now, from a pith ball. The glass rod is missing 4 times 10 to the 13th electrons. Now, this is a common mistake. Don't make this mistake. That's like N. That's the number of electrons that are missing. That is not a charge, right? It's not measured in coulombs. That's not a charge. So that goes nowhere in this equation. So that is nowhere in this equation, right? And this is a quick little side note, right? That number that I've highlighted there, that's Q equals NE. If I want to use this equation, it goes in there, okay? But we're not there yet. We'll get there in a moment. So it says, what is the force between them if the pith ball has a charge of 6.2 times 10 to the negative 7th coulomb? So that is a Q because it's measured in coulombs. So I'm going to go 6.2 times 10 to the negative 10 to the negative 7th. So here's where I realize, and I hope, Maya, this is going to help you out. So I know I want to find the force. And if I want to find the force, I have to use this equation. But I can only use this equation if all the other variables have numbers. And what I soon discover is one of them does not have a value. And what that means is that, I need to start with this equation to find that Q2. And then once I find it, I'll plug it in over here, and then I'll be able to solve for the force. So Maya, does that help you? Does that address the question you asked a little bit ago?
Yeah, so like could you just plug everything into this the F equals and then like whatever you're missing, then you plug it into the second one?
Yes. I think I followed what you said, and that sounds like what I was saying.
Yeah.
Okay. So I'm going to give everyone a minute. Give everyone a minute to try this. Oh no, we only have 2 minutes left. So I will just quickly kind of work through this, I think. So let me try and do this for us really quickly. So I want to solve for this Q. So I'm going to do Q equals N. So this will be my first step. Number of electrons is that. So 4 times 10 to the 13th. We know E is 1.6 times 10 to the negative 19th. So I got, like I said, I got the calculator app on my phone. So I'm just going to quickly plug that in here. Where are you? Archimedes app. There you are. Okay, sorry. Oh, I have it left over from last class. So that comes out to be 6.4 times 10 to the negative 6 coulombs. Now that I have that, I'll plug it in to there so that I can now solve for the force. So I'm going to take that stuff I wrote over here. I'm going to scooch it over so I got space for that. So I will erase this Q2. And instead of Q2, I'm going to plug that number in that I just got. So it's going to be 6.4 times 10 to the negative 6th. And now I'm going to put all of this into my Archimedes app. And so I'll let you guys watch me do that. So I'll pull that up. I'm not going to. Okay, there we go. And that will allow me to solve for the force. So quick, I'm going to switch over to Archimedes here so you can watch. So I'm going to do 9 times 10 to the 9th times 6.2 times 10 to the negative 7th times 6.4 times 10 to the negative 6th divided by 0. 0.06, and don't forget to square. So we go 9.92 newtons is the force. Anybody get that before me? Out of curiosity. A couple of us did. Cool. So again, here's what I can tell you, because we're going to say goodbye now. We got our summative tomorrow. I've been completely transparent about this. And so I just want to make sure that you remember or, know that what is going to be on the summative is exactly what we saw on the formative, right? And so what is that? Well, it's going to be 3 LT5a questions. So go to the formative right here. So there's going to be 3 LT5A questions, 1, 2, 3. But 2 of them, like on the formative, number 1 and number 3, 2 of those questions will be multi-steppers. And 1 of them will be just Coulomb's law, okay? Now on the formative, you solve for force. I don't remember for the summative. They may have you solve for Q1 or Q2 or distance. I don't know. But it will be a not multi-stepper. So you see 2 multi-steps and 1 not multi-step. And then for LT5B, you'll see 3 of those problems, okay? Lots of things to study. Like I said, I'll send an email out just summarizing all of them. And I'll send an email out with links to videos from the last 5 days of classes, so that if you want to go back and watch any of these, you can. And Marissa asked me if I'll send out these notes. I can, Marissa, but just real quick, the answer key is there. Is that okay? I think, to be totally fair, I think the answer key is more neat than my writing. But yeah, so what we just did today was this, and the answer key is right there. Is that good enough for you, Marissa? I would assume so.
Yeah.
Okay, good. Okay, good. Anyway, if you have any other questions, guys, stick around. Otherwise, happy studying, and I will see you tomorrow. Goodbye, everyone.
Thank you.
Thank you. See you tomorrow.
Yeah, thank you.
Mr. Boast, I had a quick
Yeah.
question.
Yeah. What is it, Maya?
So can you re-answer what Megan asked last time about how to figure out what's a multi-step problem and what's a single step?
Yep, I sure can. Give me 1 second. Jordan, Jahanzeb, are you guys still here or no?
Yeah.
Yeah.
What questions do you guys have?
Okay, you can go.
For the fourth one, why do you multiply 9 times 10 to the 9th and the 2 charges and divide that all by 0.06 squared? Shouldn't you only do the 2 charges divided by 0.06 squared?
Oh, algebraically, it doesn't matter. You can put it in the numerator or not. It's
It'll
the
be the
exact same
same
thing.
thing. It'll be the same thing.
Yeah, you get the exact same answer either way.
Okay, thank you. See you tomorrow.
Yeah, sure. Jahanzeb, what was your question?
My question was for number 3.
Mm-hmm.
You got you had to solve for Q2,
Mm-hmm.
and then I remember in Archimedes you divide 0.5 and then 430,000.
Yeah.
And then after that, where'd you get the 1.6 e minus 19?
For number 3.
I'm kind of confused after.
Oh, this right here. Where'd I get that? Is that what you mean? 1.6 times 10 to the negative 19th?
Oh wait, so once you do 0.5 divided by 433,000, and then you get that answer, you divide that by 1.6 e minus 19.
Yeah, because the 1.6 e minus 19 is this e right here.
Okay.
And so the 430,000 is this q. So, but if we want to find the n, we got to divide that to the other side.
Oh, okay. I get what you mean now.
Perfect.
Okay. Yep.
Great.
Okay, thank you.
Awesome. Thanks for waiting, Maya. Yours was just a bit of a longer question, I think. Maybe not. We'll see. So I'm going to talk through number 4 again, okay? And so I start reading number 4. It says a glass rod is brought 0.06 meters away from a pith ball. The glass rod is missing 4 times 10 to the 13th electrons. What is the force between them? Okay, so since it's asking about force, I know I'm going to be using this equation. Is that good? You with me?
Yeah.
Okay, so if I'm going to solve for force, the only way I can solve for force is if I have all these other values, because I have to plug them in to solve. Does that make sense?
Yeah.
So I start plugging them in. So I start looking through. I see, okay, so I go back to the problem. A glass rod is brought 0.06 meters away. So I've got this. the distance. The glass rod is missing 4 times 10 to the 13th electrons. That number doesn't belong in this equation. Do you understand that?
The electrons.
Yeah.
Okay. Yeah.
Okay. So then I'm just going to skip over that. What is the force between them if the pith ball has a charge of 6.2 times 10 to the negative 7th? So that's like the charge here. And I'm obviously an okay. So, but I'm done. I'm out of numbers. So what I see is that I can't solve for force because I still don't know this. I've got an extra unknown.
Hmm.
So that's how I know this is going to be a two-stepper, because I need to find that unknown somewhere else. And so I come over here and I use this equation to find that unknown.
Okay. So
And
with
then
this,
once I found it, I can plug it in here for Q2.
okay. So with a single step problem, you would only would you start by plugging in the F? Would you have to?
Something, there'd only be one unknown. So maybe it would be the force, maybe it would be the Q1, maybe Q2. You'd have all the other values that you would need.
Okay. So if the problem's asking about electrons, I should probably try number 1 if it's a single step problem.
Yes, exactly.
Okay.
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 All right. Perfect. Thanks, Maya.
Thank you. Bye.
Bye.